So welcome back to the channel and welcome back to this series of videos for December 2024 where we're looking at the IBM PS2 model 3286. So what we've done so far is shown it's working, we've taken it apart, tried to service the floppy drive which hasn't gone very well. We know the hard disk doesn't work very well. So part 2, which is this video, is going to be covering cleaning of the unit, seeing if we can get an alternative floppy drive to work. I've got a plan for that, but if not, we'll think of something else. But by the end of this video, hopefully we'll have a nice clean looking unit. I'm not sure how much we can do for the monitor, but we should have a clean base unit and we should have an operating system on that complex flash card. So hope you like part 2. Let me know your comments below. So for the top cover, I'm just going to take that off and clean it under hot soapy water. That should work quite well. And basically I'm going to try and do the same for the faceplate. I'm going to try and get this off in one piece and then run that under hot soapy water to see if we can get it nice and clean. I've already vacuumed the inside and it's okay. I mean, if I had a large enough ultrasonic cleaner, I would clean the motherboard, but we don't have access to that, so we're just going to leave that as it is for now. It's clean enough, but we'll try and get this front cover a little bit cleaner. So to get the front cover off, it looks like we need to pop these little plastic clips and this should just come off. Having watched another video recently, I think there might be some clips underneath the hard drive caddy, which means it might be tricky to get to those, but these all look straightforward. This one's got a plug in it. I think that's to stop it from working loose over time. But let's try and get this front cover off. So I'm assuming we just pull this out. Yep. So yeah, this little plastic clip was making sure that was really secure. So I've always done these in the past with pliers, trying pushing in the sides, but I'm worried I might break some off. I'm just wondering whether using one of these hollow tipped hex spanner things will work instead. Let's give it a try. Perfect. If anything, that's a little bit too big. Let me get the next size down. Yeah, it's kind of working. Seems to be fairly effective. There's one down here at the bottom you probably can't see, but that seems to be working. Okay, as a technique, it's working very well. I like it. Here's another one. I'm going to take out the hard drive and the floppy drive so I can get to those bottom clips. That means taking off the front covers, which we did successfully before without breaking anything. There we go. Haven't done this one yet. There we go. So the hard drive doesn't want to come out. That's due to this pin here holding it in. A bit like the one that was in the front of the case. Very similar little plug. Hopefully the hard drive will come out now. Very easily. So it looks like you do have to take the hard drive and the floppy drive out because this front cover looks like it extends into the bottom of the bays, and there's these little clips at the bottom to release it. I need to unclip this as well because this is part of the front assembly, I think. So let's clip this out of here. Yeah, I might leave that on at this end for now. So most of the clips now seem to be loose apart from the two at the bottom, which are proving slightly problematic. There's these four detents across the bottom of the case. I don't know if they're intended for you to use them as a pry area, but certainly the clips on this side are free. This side not so much. You can at least pry it up. Indeed, I think that is what they're for. So the front of the case is now free. These two clips did need to come off, so you did need to take the hard drive and the floppy drive out. And that just comes off as a single piece. Didn't need to do the power switch as it happened, so let's put that back. And there is this one little clip here in the middle at the bottom which is inaccessible from inside the case, so I think you have to use those little detents in the bottom to force that last clip out. There's 4 detents in the case and there's 4 clips, so I'm guessing that's what that's for. Got a slightly large area that we can vacuum now as well, which is excellent. So I can't control the lighting in here enough to make it worthwhile doing a before and after, but trust me, that looks quite a lot better now that it's been just cleaned with soap and water. So we'll let that thoroughly dry. In the meantime, let's have a look at the monitor, see if we can do anything about that. Let's quickly clean up underneath, including this lovely dead spider. Let's clean up this power switch as well. It's quite grubby. I quite often do that with my cotton wool buds, just squash the end of them with a pair of pliers and you can get into some narrower places. So the monitor's a bit of a different problem. There's quite a lot of yellow around, and I think it is actually the paint that's discoloured rather than anything that's on it. So I'm not sure how well I'm going to be able to clean that. I'm definitely going to be able to clean the dust and the grime off it, off the plastics. This fabric covering, I don't think there's an easy solution to that apart from to remove the whole thing. It's got 1, 2, 3, 4, 5, 6, 7, 8 cuts in it. You know, there's no way we can repair that and make it look any good. So I think just taking it off, it is going to reduce the contrast a little bit, but I think that's probably the right thing to do. Around the side here, you can see the problem with the yellow. So it's kind of like I think it's the underlying plastic. In this part, I think it's just scratched through the top coat, but here I think it's just not been painted very well or whatever, because it's very yellow in the seam there and around the controls. Some of it is dust, definitely, but I'm not sure how clean I can get this, but we're going to give it a go. I've been cleaning the front section only for about 10 minutes and it has improved it a little bit, but none of these yellow marks are coming off. I think they're intrinsic to the plastic, and even the bits that are definitely good dirt are not coming off very, very easily. This bottom panel, I can't get this yellow stain off, which I think is some kind of cement or something. So I'm not sure how much time I'm going to spend fixing this up, because being a monochrome monitor, I'm not sure we're going to use it that much anyway, but it is nice to have, and I will continue to clean it. I will continue to clean it in general, but I don't think I'm going to spend hours and hours on this, just because I think the reward is going to be minimal. I'm really in two minds about what to do about this cover. I'm in two minds about whether to show it on camera, what I have decided to do with it, and I'm just going to basically cut it off. And disassembling it and taking it off from the actual rim would be the best way of doing it, but I'm just going to use a Stanley knife and cut it out, so we'll see if that works. This may or may not end up in the final edit. There we go. Apologies to those purists who are screaming at the screen at the moment. I didn't think there was really any other way of dealing with that. It may be possible to get the replacements. I mean, it is essentially just kind of like a nylon silk fabric. So you could be able to refilm it, I don't know. But it's come out pretty easily. It hasn't left any residue. a little bit just there. And now we can at least clean the screen, which is quite dirty. Interestingly, when that film was in place, you couldn't quite see. There's a little bit of burning, which is now visible. It wasn't obvious before, but it is there now. It's not terrible. I didn't notice it at all when the monitor was on previously with that film in place. Now the film's not there, we can be a little bit more aggressive with our cleaning of the bezel. Alright, I shall continue to clean the rest of the surfaces, but I probably won't film that. So we haven't really spent any time looking at the monitor, so I'll just quickly go over it now. So it's the IBM PS2 monochrome display. So on this side, as shown previously, there is the contrast and brightness levels. This is after clean, by the way, so this is as clean as I can get it. Around the back it's very basic, just a IBM logo with a model number and an information sheet for compliance, and a captive VGA lead, standard IEC lead for power. It's quite a compact monitor, it's quite short front to back, as you can see from the sides, and on this side we've got the big red button. So quite a nice little compact monitor. Underneath there is a tilt swivel stand, which is removable. Okay, let's get this back together. There we go, just needs a good firm push to get it back together by the looks of it. I'll put this plug back in to here. Less likely to come apart that way. And just there is the hole for this plug, which I may not be able to reach. Oh, yep, that went in fairly easy. Let's get the lid on. There we go. That does look quite a lot better, particularly across the front. I've never seen an IBM PS2 that's needed retro brighting. They all seem to have kept their colour pretty well, actually. So put the case back on, and let's put some rubber feet on the bottom. So I happen to have these rubber feet just in my random bits of parts, and they are the perfect fit. So let's clean up these holes and put these in. That came off easier than I was expecting. Not sure where I got these from. 3M branded adhesive, hopefully it really is. They should work in there really well. So how does it look with the monitor on the top? Well, it looks pretty good actually. The screen is more reflective without that extra coating on it. Now then, we've cleaned it up as much as we're going to. Let's try and get some software onto it. So here's the floppy drive connector cable, which runs under the board and then over to the floppy drive. And it's got more wires than normal, but it is just a normal connector here on the board. J12 in this particular case. And this is the back of a floppy disk drive. So what you got here is a load of pins. These are for the data and this is for the power. I'm wondering whether a set of DuPont cables can basically hash me up a cable that separates the data from the power. And I've got female-ended DuPont cables on both ends, so that should just work. If I can get the pins in the right order, that's probably going to be the trick. So let's try and find some documentation. Having done some more research, I'm getting slightly conflicting reports about which pin out on here goes to which pin out on here. And I don't want to blow up my hard to replace motherboard or memory, so in fact we're not going to do that. So Techselect in America have the correct cable that would go from this edge connector to a standard floppy, which would work, but and it's reasonably priced, but the cost to post for America is significant, so that isn't going to work for me. So I think we can go back to plan C, which is to take this compact flash card, put it in an IDE to compact flash adapter, put it in a separate system, and then boot off some floppies and install DOS onto it on another system. I think that's probably the best way of doing it just at this point in time. Certainly that's the safest way of doing it. So this here is my bridge machine. It's a socket 775 based motherboard with a G41 chipset, and it's brilliant because it covers IDE, floppy, SATA. It's got PCI, it's got PCI Express. It will run anything from Windows 98 SE up through to Windows 10 and lots of different versions of Linux. So we're going to use this machine to write some floppy disk images of PC.2 5 because mine's currently in storage, and then we're going to attach the compact flash card to a compact flash to IDE adapter, and then boot off the floppy and write the image directly to the compact flash card from the floppy disks. At least that's the theory. So I was going to use Linux to write these disk images, but as it happens they are 720k images and I've only got 1.44 megabyte floppies available that are spare, so I've come into Windows instead, and we're going to use WinImage to change them. So what you can do with WinImage is you change formats, and we can change them to 1.44 megabytes. One down, 2 to go. So next we're going to put the compact flash into the compact flash adapter, configure it in the BIOS as the primary hard disk, and then boot off the floppy. So it's already detected it as the primary IDE drive. It's detected it as 32 terabytes though, which is definitely not right. It's 512 megabytes. That could potentially be a problem. Let's see if DOS will boot and if DOS will detect it. Well, sounds like DOS is booting, so that's good. So it cannot be installed on your hard disk because all the primary partition table entries in hard disk are already in use. So it may be that this compact flash card has already got a file structure on it that this doesn't understand. That's the most likely reason, isn't it? Oh look, IBM F-disk is blue. Who knew? So display the partition. So yeah, it's very confused about what's happening in the partition table here. So let's go and delete all of that. And there we go. So we've tidied up that horrendous mess. Let's create a single DOS partition filling the entire space. Has it made it active? It has, so we don't need to do anything else. It's created a 2 gigabyte partition, which is incorrect because it's only a 512 megabyte drive. So let's try and resolve that. Okay, it seems a little bit happier. Okay, setup is completed. That was pretty quick, but then again, this has got a very modern CPU. Okay, that was a bit crazy because Windows 98 isn't on that compact flash anymore. Let's just check what's on the hard disk. So it appears to be functioning correct. It says the partition type is non-DOS. Check disk is working. But again, it reckons it's the wrong size partition. Okay, we're half working. I think it's working enough that we can put this compact flash card back into the IBM and see if it at least boots. Okay, so we've reassembled the PS2. Compact flash is in the back. Let's switch it on. It says it's booting, but we are not getting to the DOS prompt. So in fact, maybe we haven't yet resolved this, or it could be a problem with the XT-IDE. Now that could be because of this partition that's larger than the card. So let's try and resolve that. So what I've done is two things. One is I've used a partition manager to make sure that partition is 1 megabyte smaller than the card. But I've also got it to update the master boot record. Now I don't know if that was a wise decision, because it's going to use a much older, a much newer MBR than DOS 5. Let's see if it will boot. Unfortunately not. So I've just put the Amstrad card back in just to make sure it still will boot in the system, which it will. So I think the next thing to do maybe to, maybe to clone this card onto the other card and then manually copy over the files we need for DOS 5.5. Okay, so we've copied the Amstrad partition over to this compact flash card to see if this card actually works. While I was doing that, I looked at the partition that had been created by DOS 5, and it was very weird because it was 95% full already, which doesn't sound correct. So let's see if we can boot off this smaller 30 megabyte partition. Okay, well, we've got further than we did before, but it's not bootable. So my plan is now to take this card, this compact flash card, and put it into our bridge computer to boot off the DOS 5 floppy, sys the partition, and then copy over the DOS files manually and see if that makes it a DOS 5 partition. Okay, so let's see what fdisk makes of this new partition, this new old partition. So it's recognised it as a primary DOS partition, which is great. FAT16 file system. It says it's the active partition, so I'm surprised it didn't boot straight away. Here, so that whoops. So that should have created a fresh master boot record from this floppy. Hopefully that's worked. Let's have a little look. We can read this fine. So let's just try sysing it and see if that makes a start. So sys is on there, but it isn't expanded yet. Format's on there. Should we try formatting the partition and then just running the setup? Let's do that. Okay, so it's not repartitioning the disk, which is what we wanted, so that is great. So can we boot off this compact flash in this very modern machine? Yes, we can. Perfect. Look at that. Okay, so now we know this partition works. It's very likely it's going to work in the PS2. That is amazing. Let's do some other stuff then. So what I'm going to do is I'm going to run fdisk from within DOS 5 that we just booted off this compact flash, and if we go back to just looking at the partition, so we've still got this single 30 megabyte partition. That's pretty small. We've got plenty of other room on the compact flash card, so let's make another partition, or a couple of partitions, that we can install some software onto. It seems more happy with the size of the disk now because it's offering the 487 megabytes, which is the rest of the partition, so that's good. So we've got this extended partition now, which we can fill with logical drives. So across the top we've got drive D, which seems to be the same as drive C. That's a little bit weird. I've created drive E, but we haven't formatted it yet, so that's why it's giving an error. But I'm not sure why we've got two drive Ds. Two drives here, which is a bit of a concern. It's all right, we're back. So we've now copy some stuff over onto the compact flash card, put it back in the machine. We're just about to boot. Hopefully it still boots. Okay, seems to have booted, although it's unhappy about something. What is it? Okay, AutoExec BAT's got 189 bytes in it, but it appears to be empty. That's concerning. So D is the second partition where I've put a load of files that might be of use. Let's go to G-Setup. Let's go to G-Setup. So G-Setup is a generic setup, hence the name, for configuring the settings in AC class machines before we had a kind of proper BIOS. So let's run that. It should be able to get rid of those 161 and 163 errors. Let's get the time correct. Well, time's actually still hanging on, so that CMOS battery must be working correctly. The date is also correct. I've kept it at year 99 just because we don't want to confuse it with any year 2000 problem. So we need to configure the floppy disk drive. It's currently not defined, so let's tell it what it is. It is a 3.5 1.44 megabyte. So the second floppy disk is not installed. Hard disk C is installed, but I don't, because we've got a separate BIOS for that, we don't need to have it configured in here. 6 base memory we're going to put as 640, and the expanding memory we can use the cursors to change. Not installed with mass code processor. Primary display is 4. That is correct. Okay, so expansion memory. So this has got 1 megabytes of RAM. So we've got an extra 384 megs that we can put in there. All right, so hopefully we should know how to get rid of those 131 and 163, sorry, 161 and 163 errors, and it shouldn't complain. We should just get straight through to the boot menu. It's the first time I've used this. I didn't realise that it was actually shareware or donationware, as the case may be. It's from 1988, so I suspect this is no longer valid. I might look into that actually. Is it going to work? Is it going to go straight through to the boot menu? Now, interestingly, the boot drive, the floppy disk drive, actually spun up and made a noise at that point. So I'm wondering whether actually the floppy drive is working a little better. Let's put something in it and find out. So it's making the right noises and is displaying a directory, but we did that last time, but we couldn't run any programs off the floppy drive. Should we try running setup? Yeah, so it's still not working, but it's actually working more than it did before. So the floppy drive is still kind of half working. So okay, so I've installed Norton utilities on the C drive just so that we can just check these partitions, make sure they're working, because it did seem that there was some weirdness going on. So bearing in mind this is the monochrome display. Okay, so no problems were detected on drive C. Let's try drive D. So there is a problem on drive D. Okay, that doesn't surprise me. So I'm just going to have a quick look at the AutoExec. It concerns me that it's 189 bytes big, but has got nothing in it. So having some problems with disk corruption. This is the file listing of Jill of the Jungle 2 directory, and as you can see, it's completely crazy. The file name seems to have been replaced by text of a file. I'm having some corruption issues on this XT-IDE compact flash combination, so I'm just going to try something slightly different before we progress. Right, I wasn't going to show you this monitor this week because it's part of next week's video, but the PicoMEM boot menu doesn't work in monochrome. You have to have a color monitor for it to show the colors correctly. So I've had to switch from the monochrome monitor to a color monitor, and this is the first one I had to hand. Ignore the flicker, that will go away in a minute. So here we are, we're in the PicoMEM pseudo BIOS. It seems to be working from that point of view. We probably need to configure some hard disks and load up some floppies. Apparently on the model 3286 EMS doesn't work correctly on the PicoMEM, so let's not mess with that. So let's create a hard drive that we can use. So we need to keep it fairly small. If we're using DOS 5, in theory it can use up to 2 gigabytes, I think, as a partition. But let's just keep it fairly small. So we're going to give it 500 megabytes. We're going to be installing PC-DOS 5 on it, so let's give it that as a name. Okay, so we're now creating a 500 megabyte image for PC-DOS, and then we're going to install that. So the advantage of PicoMEM over the XT-IDE is that it also emulates floppy disks, so we should be able to just load some disk images into the drives and just copy them and install them. So PC-DOS 5 disk 1, there we go. We haven't got any hard disks defined, that's probably what it is. Now we need to have the boot code on, otherwise it can't boot. Okay, that all now makes much more sense. So we're going to boot from the floppy, which we've done. And we're going to try and install it to the hard disk. And see if this works. Okay, maybe it was rebooting because it had finished its F-disking. Okay, I had to inject the command pminit into the PC-DOS 5 boot disk using WinImage so that we could load this menu from within the setup program, otherwise you can't change the disks. Otherwise it now seems to be working quite well. Okay, yeah, brilliant. We've booted straight into the hard drive. DOS 5.02, and we should end up with a DOS shell. Maybe. Yes. There we go. Okay, so PicoMEM has worked very marginally better than the IDE XT-IDE. It's possibly a little bit slower, I think, in terms of the disk performance, but overall it seems to be working better. So let's install some other software and have a play. Now that we've got PicoMEM running, we can actually run the IBM configuration floppy disk, change some of that. So the memory is correct. This is correct. That's also correct. Let's enable. There we go. Okay. Hopefully that will now negate those errors that happen when we boot up. So I've just affected the camera settings so that we get less flicker, but it does mean I'm going to get some motion blur in my hand. Okay, let's check it. So running DOS 5.02 from IBM 286. No mass coprocessor, we knew that already. 394K of extended memory, perfect. It says floppy drive A is a 360K drive, which it isn't. So we do need to run the config again on that. We're still getting that 163 error, which is probably what's related to that. What I'm interested in is how fast it is. So this is a 10 megahertz 286. So let's have a little look at how fast it thinks it is. And there you go. So compared to a PC XT, the original 4.77 megahertz, we are currently 5.5 times faster. And for maths, it's pretty much exactly the same. We haven't got a maths coprocessor installed. If we had, that would be probably much higher. Excellent. So that all seems about right. Let's see how fast this video card is. Okay, so it's quite a lot faster than the original XT. In this case, it's 4 times faster, 4.5 times faster. So pretty decent performance. I don't know how that would compare to, say, an ET4000. We'll have to quickly look that up at some point. Let's benchmark the hard disk. Okay, so transfer speed is 12.5 times faster than an XT. That's not a surprise. We're using a modern compact flash, essentially. A modern SD card. It is being emulated in software though, so that's pretty good. Seek times are, massively lower because it's all flash-based media, so that all makes sense. But it's a pretty reasonable performance hard disk. the processor is going to be the limiting factor on this, not the CPU. So can it play Doom? Definitely not, but can it play Wolfenstein? There's a little bit of an artifact going on across the top of the screen when there's a cutscene. Do you see that there? So it's not filling the full screen, and frame rates are poor. Probably a couple of frames a second, I reckon. PC speaker's working. So it can just about play it. It's not a pleasant experience. So, trouble with Wolfenstein 3D. Flight Simulator 3 was kind of like a benchmark test for how compatible your IBM was. So this is working very well. So it looks like we're running very much in CGA 4 color mode. So let's see if we can improve that. So let's go for the high resolution, but only 16 colors. Much more detail in the control panel here. Screen update's probably still kind of somewhere between 5-6 frames per second, I reckon. But it's definitely playable at that resolution. Of course, the most likely reason this would be used is for some productivity. So let's load Lotus 123 version 2.2. This is your classic Lotus 123 interface, the one that got people sued, with your menu up here at the top. I can't remember the formulas for this early version of 123, but you get the idea. So while Lotus would like you to use 123, Borland would like you to use Quattro, which is pretty much exactly the same thing. So this has a bit more menu that we would expect. You still use the slash key to bring it up, but instead of it being confined to the 2 lines at the top, it's now down the side of the screen because of the Lotus 123 lawsuit. But there you go. It does pretty much the same thing. Very, very similar. It's a little bit easier to move around, spreadsheet, etc. But otherwise, very, very, very similar, but cheaper. So what I also wanted to show you was IBM's version of software that was around at the time. So, for example, there's a thing called Current, and I was going to try and show it to you, but unfortunately that's as far as we're going to get. So basically it comes with a bundled runtime version of Windows 2.11. Oh, we're getting further than I've ever got before. So yeah, so this version of 286 doesn't seem to, Windows 286 doesn't seem to work quite well with this computer. But basically IBM had its own software. This is a GUI version of something called Current, which came out in 1989, the year that this machine was launched, which is why I wanted to show it to you, but it's not currently working. So there's still a few things about this computer that aren't quite working. So I think we're getting towards the end of this video. Let's just quickly show you BASIC, because this has got BASIC in ROM. So you can go straight to BASIC from the command line. And there you go. You can run straight from the BIOS without having to load anything. So there we have it, the IBM PS2 Model 30286. A lovely little machine. I'm really glad I have got this in my collection. I put a sound card and a network card in there, so the next thing to do is to get some drivers onto the system for those to have a little play, see if we can get some audio out of, for example, Wolfenstein 3D. But we can put some other games on there, some other DOS games like Chill of the Jungle, for example. The monochrome monitor is a little bit limiting, so I'm going to be on the lookout for a IBM branded PS2 color monitor. If you have one of those going cheap, let me know. But otherwise, I'm really happy to have this in my collection. I think aesthetically, I love the look of it. The monochrome monitor doesn't matter for the productivity side of things. You know, if you were just doing word processing and some basic spreadsheets on here, or dbase, that would have been absolutely fine. Graphing, you probably would have benefited from some color. and you probably wouldn't be using this for doing DTP. You probably want a 386, but it's twice as fast as the model that it replaced, the non-286 version, the 8 megahertz A286. It's about twice as fast as that machine, and got better graphics. So overall, a very capable machine. Definitely going to be keeping this, and there may be a future video coming up when I've got those other drivers on there for the extra add-in cards. But I hope you enjoyed the video. It's been a little bit frustrating to make with things not working, like the floppy drive and the hard drive, but PicoMEM came to the rescue and helped us out there. If you enjoyed this video, don't forget to give it a like, and we'll see you in the next one.